Okay, this video is to help you solve systems of equations using the elimination method. If you hear any noise in the background, I apologize. I'm having my deck pressure washed. My first example is 2x minus y equals 4 and 3x plus y equals 1. So the first thing you want to do is make sure that your system is set up so it looks like this. Ax plus by equals c. You want to have all your x's lined up, all your y's lined up, and your constants lined up. All right, this one is set up perfectly for us. We have 2x minus y equals 4, 3x plus y equals 1. Our goal is to combine the two equations so we have one equation with one variable instead of two equations with two variables. The next step is to look at your coefficients and see if you can combine them without doing any work, such as multiplying by a constant. So for the x's, I have coefficients of 2 and 3, and for the y's, I have coefficients of -1 and +1. So I can combine these two equations. If I would just add these two together, the y terms would disappear. So that's exactly what I'm going to do. 2x plus 3x is 5x. My y terms disappear, and then 4 plus 1 is equal to 5. When I divide both sides by 5, I get x is equal to 1. Now, just like we did when we used substitution to solve a system, we're going to take this variable and substitute the value back into either one of the original two equations to solve for y. I'll just pick the first one. It does not matter. You can plug it into the first or the second one. So I'm just going to rewrite the equation over here. 2x minus y is equal to 4. We solved and got x is equal to 1. So 2 times 1 minus y is equal to 4. 2 times 1 is 2 minus y is equal to 4. If I subtract 2 from both sides, I get negative y is equal to 2. And I'm solving for positive y, so I'm going to multiply everything by -1, and I get y is equal to -2. If you write your answer as an ordered pair, it must go in a set of parentheses, x, comma, y. Now, the most important part is to check your work. Always check your work. All right, so we're going to check 1, -2 in both equations. Remember, it has to work in both equations, otherwise it is not a solution to the system. Okay, so the first one I have 2x minus y equals 4, and the second equation is 3x plus y is equal to 1. So 2 times 1 minus -2 equals 4. 2 times 1 is 2, minus a negative is plus 2 equals 4, and I get 4 is equal to 4. So it works for the first one. If it works for this equation as well, then I know that 1 -2 is correct. 3 times 1 plus -2 is equal to 1. 3 times 1 is 3, plus a negative is the same thing as minus. It's 1, and I get 1 is equal to 1. So I know that 1, -2 is the solution to this system. My second example, 4x plus 3y is equal to 6, and 2x minus 5y is equal to, 4x plus 3y is equal to 12, and 2x minus 5y is equal to 6. Again, make sure your x terms are lined up, your y terms are lined up, and your constants are lined up. So we don't have to do any extra work with that. The second thing I'm going to do is look at my coefficients. I have a 4 here and a 2 here, 3 here, and -5 here. 4 is a multiple of 2, so I know I would only need to multiply one of my equations by something so I can get rid of one. I'm just going to rewrite the system down here so I have a little bit more room to write. Okay, so if I multiply this second equation by -2, that's going to give me a -4x here, and I can combine these two and the x term would disappear. So I'm going to rewrite the first equation, 4x plus 3y is equal to 12. And now I'm going to multiply the second equation by -2. Okay, multiply everything in the second equation by -2. -2 times 2x is -4x. -2 times -5 is plus 10y. -2 times 6 is -12. And I'm going to add these two equations together. 4x plus negative 4x cancels. 3x plus 10x is, 3y plus 10y is 13y. And 12 plus negative 12 is 0. Divide both sides by 13. I get y is equal to 0. Now what I want to do is plug 0 back into either one of the original two equations so I can solve for x. And I'll just pick the first one, it doesn't matter. 4x plus 3 times 0 is equal to 12. 4x plus 0 is equal to 12. So 4x is equal to 12. Divide both sides by 4. I get x is equal to 3. So again, if you write this as an ordered pair, it must be in parentheses, x coordinate, comma, y coordinate, 3, 0. And then we're going to check our work. So I want to check 3, 0 in both of these equations. The first one is 4x plus 3y is equal to 12. And the second one is 2x minus 5y is equal to 6. 4 times 3 plus 3 times 0 equals 12. 12 plus 0 is equal to 12. 12 equals 12. So it works for that one. Now I'm going to do the same thing in the second equation. 2 times 3 minus 5 times 0 equals 6. 6 minus 0 is equal to 6. 6 is equal to 6. So I know that 3, 0 is correct. Okay, the last one that I'm going to do on this video is example number 3. And it's 7x minus 3y equals 6 and negative 2x plus 5y equals negative 10. My x's are lined up, my y's are lined up, my constants are lined up. Look at my coefficients. I have 7, negative 2 for the x, and negative 3 and positive 5 for the y. This time I'm going to have to multiply both equations by something to make it possible for me to eliminate. So I want to get rid of the x. You can choose to get rid of the y. It does not matter. One easy way to do this would be to multiply by the opposite coefficient for that particular variable. So for the top equations, I'm going to multiply by 2. Okay? And for the bottom equation, I'm going to multiply by 7. 2 times 7x would give me a positive 14x. 2 times negative 2x would give me a negative 14x. So that's what I'm going to do. So 2 times the first equation would give me 14x minus 6y is equal to 12. And then when I multiply the second equation by 7, I get negative 14x plus 35y is equal to negative 70. And I want to add these two equations together. 14x plus negative 14x is going to cancel. Negative 6y plus 35y is going to give me 29y. And then 12 minus 70 is, what is this, 58, negative 58. Divide both sides. Divide both sides by 29. And I get y is equal to negative 2. I'm going to plug negative 2 back into, I'll pick the second one this time. Negative 2x plus 5 times negative 2 is equal to negative 10. Negative 2x minus 10 is equal to negative 10. Add 10 to both sides. I get negative 2x is equal to 0. Divide by negative 2. When you divide 0 by anything, it's just 0. So as an ordered pair, 0, comma, negative 2. Now we're going to check to make sure that it's correct. So we're going to check 0, negative 2. All right, the first equation, I would get 7 times 0 minus 3 times negative 2 is equal to 6. 0 plus 6 is equal to 6. 6 is equal to 6. So it worked in the first equation. Now we're going to try the second one. Negative 2 times 0 plus 5 times negative 2 is equal to negative 10. 0 minus 10 is equal to negative 10. Negative 10 is equal to negative 10. So I know that this answer is correct. I'm going to do another video that will illustrate the special circumstances when you're solving using an elimination, where you would have a system that is inconsistent and a system that is consistent and dependent.